Designed for comfort, grounded in efficiency, and built to last. Carrier geothermal comfort systems take reliability to the next level. That commitment to quality is the foundation of our century of success. With our geothermal systems, it starts with a world-class manufacturing facility, highly trained and motivated engineers and manufacturing technicians, and tightly controlled processes and technologies to deliver quality and reliability you expect from Carrier. Let's take a walk through our factory here in Fort Lauderdale to see firsthand how we deliver upon our promise. Long before parts make their way along the assembly line, skilled engineers precisely design the units using sophisticated software tools to optimize form, fit, function, and performance. Every detail of the unit's design is documented. Hundreds of components are included in every unit, from major components like compressors, heat exchangers, air coils, blower motors, and controls, down to wires and screws. Component selection includes a thorough evaluation of performance, reliability, and compatibility with the overall system. The suppliers of these components must meet rigorous quality and reliability standards to be selected. Once the unit is designed, prototypes are built and thoroughly tested. A structured process documents all the product development steps and requires periodic reviews by the design team and senior management before new units are approved for production. To ensure the highest build quality, our staff is specially trained for all critical processes, with an emphasis on brazing. With the number of copper-to-copper connections, properly brazed joints are critical to long-term reliability and efficiency. Now let's take a look at the unit production process. We know that once you see the manufacturing system and all its quality control processes along the way, you'll have confidence in knowing that Carrier geothermal products are among the best in the industry for reliability, durability, and performance. All unit components are delivered by qualified suppliers, checked for damage, and stored for later production. Random inspections are performed to ensure the components meet specifications. Components and subassemblies are staged in separate bins. Detailed, graphic assembly instructions guide the entire process, and daily production reviews ensure all methods and procedures are up to date. To match the right component to the right unit and ensure that the correct test is administered, each product's barcode is scanned throughout the process. Once the work is completed, tests have been passed, and the checklist filled out, then and only then will the unit advance to the next station. Of course, a major component of a geothermal unit is the sheet metal cabinet. Carrier units are finished with an attractive and durable taupe metallic paint. A protective plastic film covers the sheet metal to prevent scratches or blemishes during production. The sheet metal is punched using high-tech machines with computer programs to ensure precise fit. Insulation is carefully cut and added to the interior cabinet pieces for quiet unit operation. In another subassembly operation, copper tubing for the refrigerant lines is cut and bent into sophisticated configurations to minimize the number of connections. Thermal expansion valves and reversing valves are expertly brazed into the copper pieces. Nitrogen is fed through the copper tubing during this process to prevent oxidation inside the tubing during brazing. They're staged for installation later on the assembly line. Next is the control box assembly. It includes many electrical components, contactors, transformers, relays, and wiring harnesses. Due to the wide variety of units, there are many control box configurations with various complexities, so assembly technicians refer to detailed instructions to ensure all necessary components are included and wired properly. Now that we've reviewed the sub-assembly areas, let's take a look at the main assembly line. The process begins with the base pan and cabinet corner post. The unit's coaxial heat exchanger is insulated, installed, and pressure tested up to 400 psi. Every unit on the assembly line comes with a checklist for each operator to document completion of the task done at each station. This ensures that no details are overlooked. Next, the compressor is added along with other refrigeration components produced in the subassembly area. Nitrogen again is used during brazing to prevent oxidation and debris. Additional cabinet pieces, the corrosion-resistant condensate drain pan, the air coil, and electrical control box are added along the way. Sturdy brackets are used to hold the blower housing firmly to the cabinet to eliminate vibration and noise during operation and also to prevent damage during shipping. After a power vacuum is performed on the refrigeration circuit, refrigerant is added using a computerized system which delivers the precise charge to the unit. Now the unit's poised for a thorough diagnostic testing before it's dressed for business with panels and decals. The unit is connected to the testing machine and the barcode is scanned to call up the proper test and pass-fail parameters. Depending upon the unit, up to 15 different tests are performed. Every unit must pass all safety tests, no exceptions. Other tests are conducted on the controls, compressor, blower motors, refrigerant circuit, and other components. If a component or function does not pass the test, the operator cannot move the unit along the line until the error is found, corrected, and the unit passes the retest. Test results for each unit are saved for future reference. Only after all tests have been successfully completed can the unit's data plate be printed. Then additional unit panels are added along with decals, unit badge, and the installation instructions. Prior to the last panels being attached, a final quality control examination is performed and the checklist is reviewed for completion. The unit is then placed on a sturdy skid and one last ultra-sensitive refrigerant sniff test is performed. Finally, it's carefully packaged and prepared for shipping. So that's a wrap. By the time a Carrier geothermal comfort system is put into service, it's been through one of the most thoroughly controlled assembly processes in the industry. As a result, you can be confident it will deliver the comfort families want, one of the lowest operating costs in residential heating and cooling, and long-term lasting reliability that we all can appreciate. On behalf of the entire Carrier team, thanks for touring our geothermal system factory.